Great. Thanks so much, Hunter. I want to go ahead and introduce Dr. Sarah Lyons. She was kind enough to agree to do this session. We talked about this quite a long time ago, didn't we, Sarah? So Sarah is the scientific project manager with the Foundation for Food and Agricultural Research and leads the Efficient Fertilizer Consortium. She has an interdisciplinary background in soil fertility, nutrient management, agronomy, and beef and dairy nutrition. She has a master's in animal sciences from North Carolina State University and a PhD in animal science from Cornell University. And she did her postdoc in crop and soil sciences from right here, NC State University, with the Fertilizer Recommendation Support Tool Initiative. So, Sarah, thanks so much for joining us.
Much, Matt, for inviting me. I'm really happy to be here with this group and to see some familiar faces and meet some new ones. So I am the session moderator, but Matt allowed me a few minutes to talk about our initiative at FAR that's very relevant to the topic of today's session. For those of you who aren't familiar with FAR, we are a nonprofit organization. We were started by Congress in 2014. We received funding from Congress, but we have to match that money from Congress at least one-to-one with external partner funding. So we really specialize in public-private partnerships to fund research together. And I think it's truly a superpower to get to collaborate with folks from different areas of the industry. And I think that's a power of this conference as well. It's get to see a lot of different folks from different points of view and different angles. So I'll give a little overview of our consortium and why it exists. So real quickly, there are, as many of you know, many hundreds, countless different types of fertilizer technologies out there on the market being developed, soon to become available to farmers, which is great. A lot of them have been around a long time, and some of them are very new, but many of them show a lot of promise for reducing nutrient losses to the environment, getting more nutrients into the crop. But unfortunately, many of them lack a lot of standardized independent evaluation. So a lot of us aren't really sure where, how, when they work in some cases. And even though some of these technologies have been around since like the 60s, farmer adoption remains quite low, and oftentimes because they're expensive. But also a lot of farmers just don't have experience with them or aren't sure if they're going to work or not on their farm. So with our consortium, we're trying to address some of these concerns. And this graphic is from our white paper, if you're interested in learning more. These are just showing some examples of technologies that we're focusing on with our efforts. So the Efficient Fertilizer Consortium, or EFC, is a public-private partnership. We teamed up with 10 external partners to fund research together in this space. So we're highly collaborative. As you can see, we have a few familiar faces here: OCP, ICL. We also have some international governments, crop groups, other foundations. So we're really a diverse base of funders, all interested in this work. In terms of what we're doing, we are funding field trials around the world, evaluating different types of plant nutrition products. And before we started doing that, we actually established a common set of guidelines for evaluating these products in field trials, because we really wanted data to be able to be pooled together and looked at as one big picture, which makes it more impactful. So I'll share just a little bit more about that. So we developed the field trial guidelines for evaluating enhanced efficiency fertilizers last year. These are to evaluate both the agronomic and the environmental impact of EEFs and other novel products. Again, really, the goal is to have consistency in experimental design, data collection. We want more confidence in the data coming out of these trials. And I did want to say that, there's a whole pathway of product development. This is at near the end where we're ready to be putting them in the field. Farmers have access to them. So really focus on that post-commercialization space. And I also want to give a shout out to the amazing group of co-authors on this paper. There's a lot of them, but a few of them are at the conference. So Josh McGrath, Andrew Margonaut, and Jason Hagley are next speaker. So you can definitely peg them with questions if you're interested in learning more. And in terms of next steps for our group, so we are funding trials around the world, as I said. We'll be announcing those later this year, early next year. And then our executive committee is meeting later this fall to decide what's next. There's going to be some more funding opportunities, maybe a next round of the project as a whole. So if you're interested from either a grantee or a partner standpoint, we would absolutely love to hear from you. So please feel free to reach out. All right, and with that, I would love to dive into our first speaker here. So Jason Hagley, he's our scientist representative from ICL on our consortium, so very happy to see him here as well. As the Marketing and Innovation Manager for ICL Growing Solutions North America, Jason Hagley leads the product management, business development, agronomy, and new product innovation functions of the North American commercial business. With over 10 years of industry experience related to seed, crop protection, and plant nutrition, Hagley has a well-rounded understanding of the crop input industry, including past roles in product development and market development and agronomy sales support. Thanks, Jason. Take it away.
Sure. Good afternoon, everyone. Sarah mentioned my name is Jason Hagley. I'm based in Illinois, and I noticed we've got a strong contingent of Illinois people here today. So I've been in Illinois for about 17 years now. Came to the area as a graduate student at the University of Illinois. I received my PhD in crop sciences there back in 2012, and stayed in the area in various roles with Pioneer Hybrid, Winfield United, and now ICL in different agronomic roles as I progressed in my career. So what I wanted to highlight today is kind of kick off the discussion about innovation and product adoption in industry, specifically focused on enhanced efficiency fertilizers, or the idea of enhanced efficiency fertilizers. And so I start with this, and I pose the question of how fertilizers developed in the past, and it really is the past. It's still how many fertilizers are still developed, and it's a very simplistic process. The customer, the farmer, comes to the manufacturer, a manufacturer like ICL, and says, I need an NPK analysis of, triple 20 as an example. And then the manufacturer, thinks about, the most appropriate nutrient sources. So in this example, the water-soluble fertilizer, that could be things like monoammonium phosphate, monopotassium phosphate, potassium nitrate, etc. Chemist, puts together a blend, tests it for compatibility and stability, and then ultimately you have a finished product that can be sold into the marketplace. So although this is how fertilizer development occurred in the past and still develops to a large extent today, I think it is starting to change, and the group here today reflects some of the changes that are needed within the overall plant nutrition industry here in North America, but also globally. So with that in mind, back in 2023, Dr. Doberman and his colleagues published a paper focused on a new paradigm for plant nutrition. And as you look at this slide, there's 5 interconnected aims on the left side, and then 6 specific action items on the right side. And so the central thesis of this paper is that as we go forward, it's not just about developing fertilizers or having plant nutrition recommendations to increase yield or increase economic productivity for the farmer, but there's other problems that we also have to solve, and those include problems related to the environment, broader socioeconomic issues, and then also the idea of enhanced or increased human nutrition and health through our plant nutrition choices. So I distill this down to what I think it means for a manufacturer like ICL or the fertilizer industry in general. And the first idea that I have here is that new approaches to plant nutrition aren't going to rely on just simply combining individual nutrients like what we've done in the past with that example I showed for a water-soluble fertilizer, but instead focusing on combinations of novel technologies, not just nutrients, but also additives, biologicals, biostimulants, nanotechnology, all these different technologies that are being developed, and which we can bring together to solve broader issues and challenges in crop nutrition. And that's I think a theme through the Enhanced Efficiency Fertilizer Consortium of evaluating these different technologies and the impact they can have on reducing emissions, but also improving farmer productivity. As we think about testing methodologies for new enhanced efficiency fertilizers, it's not just about yield trials. Yield trials, relatively speaking, are simple, and I say that a little bit tongue in cheek for anyone who's actually done a yield trial. It's can be quite difficult to do a quality yield trial. But as we think about some of these other issues that we're trying to solve, emissions reduction, improved human health, other outcomes, designing the right methodology to evaluate these products becomes more challenging and more important to have repeatable data that ultimately convinces the farmer to adopt these products. And then lastly, when we think about phosphates and really nitrogen, potassium, and other nutrients as well, there's still a major focus on commodity fertilizers. And I would predict that undifferentiated, less efficient commodity fertilizers like triple superphosphate, monoammonium phosphate, diammonium phosphate are still going to be with us for the foreseeable future, and that really stems from the attractiveness of relatively low cost commodity plant nutrients. I say that with air quotes because we know phosphate markets are increasing, and these products aren't necessarily low cost. But there is a demand for these products, and as we come forward with alternative options, whether that be additives, coatings, biologicals, biostimulants, to help improve the efficiency of nutrition for nutrients like phosphorus, we really need to have a solid value proposition, demonstrated through scientifically valid local testing, and that's the one of the themes or the objectives of the EFC. And then lastly, before I move into a specific example from ICL, I think this this concept needs to be highlighted as well as we develop new products and solve unmet needs for the farmer and for the agricultural industry, and that's the the distribution model. So in essence, there's three different ways that a product can get from a manufacturer like ICL to the ultimate end customer, which is the farmer. In some cases, they can be a direct distribution model where the manufacturer sells directly to the grower. In other cases, that product goes through a local distributor or retailer and then goes to the grower. And then in other cases, there's a three-step distribution model that involves another level of distribution. But the point that I want to make with this is that it's not just about solving for agronomic problems. It's also about solving for economic problems that are being experienced at the farm gate. Right now, there's a lot of challenges with farm gate profitability, and ultimately, there's often a retailer or distributor that's responsible for selling that product to the farmer, and also in many cases, applying that product to the farmer's field. So, we can't just think about the agronomic issue, the water quality issue. We also need to think about the overall economic profitability of the entire supply chain that gets that big product innovation to the farm. So from an ICL perspective, this isn't incredibly complex, and I think many companies follow the same general type of methodology where products go through a stage gate process where there's an early stage product concept or ideation. That product is developed in the laboratory or potentially a pilot scale facility, and then it goes through different levels of testing with increasing levels of scale, starting in a controlled environment test to validate proof of concept, and then going into replicated trials with universities or third-party collaborators, and then ultimately ongoing trials with the customer, whether that be a retail distributor or a farmer. Some examples of recent ICL innovations that are really focused on enhanced efficiency across a broad range of nutrients include PureLoop, EcoX, and Bios. And the one that I specifically want to include here as an example is a product available now currently in Europe called PureLoop, which is derived from sewage, sludge ash, and phosphoric acid. So we're starting to recycle nutrients, phosphorus specifically from the wastewater treatment plant in Amsterdam, further enriching that with phosphoric acid to increase the nutrient analysis, and then providing a partially recycled form of phosphorus fertilizer that helps to address some of the regulations in Europe that now require a certain percentage of nutrients to be from recycled sources. So in terms of PureLoop, we're taking what would otherwise be a waste product or low value product that has to be applied to the land, and we're increasing the nutrient value of that product through acidulation, making it more uniform to apply through granulation, and then ultimately, again, you're making something that's economically profitable for the farmer. There's different ways to go about nutrient recycling, and so we have the STAR representation here and others that are working on this concept of nutrient recycling. but again, this is the idea of taking sewage sludge ash, which is a mud-like residue from the wastewater treatment process. That sewage sludge is incinerated to remove some of the biological contaminants and carbon-based contaminants. Sewage sludge ash then is between 4 and 9% phosphorus content as a product in itself. We then subject that to phosphoric acid treatment to help increase the phosphorus content, and then it can be combined in different ways with other nutrients like potassium to achieve the desired NPK analysis that the farmer or the customer is requesting or requiring. So in this particular product development process, we started with essentially a market need, which was the concept of taking a otherwise waste product and transforming it into a crop nutrient. There was formulation work, there was pilot scale production to validate the technical process of producing a product like Pure Loop, and then came the agronomic validation to make sure that this source of phosphorus fertilizer would perform at the same level or potentially even a better level compared to traditional sources of fertilizer like TSP, triple superphosphate. And so in this example, which started as a controlled environment or a greenhouse study, there's different treatments of Pure Loop formulations compared to a positive control, TSP in this case, a negative control with no phosphorus fertilizer, and then there was also a biological or a mycorrhizal treatment in this as well. So in this study, we showed that some of the different PK plus based or Pure Loop based formulations like 0540 and 0322 performed similarly or maybe even a little bit better compared to the positive control, which was TSP in a controlled environment in a pot study. Here's another example of some visuals from the trial where on the right side of this photo, we have the negative control receiving no phosphorus, phosphorus with a mycorrhizal fungi. So you can see the biological incremental addition from the fungi, and then the different phosphorus fertilizer sources, either TSP or the Pure Loop based products. And then ultimately, these product concepts are also going through field trials as the next step of that common industry type of approach to validating products, and then ultimately to a commercial launch where they'll be available to farmers in the European market. So.
Couple questions, I think, and then we'll get Fred up there. Hang out for a minute. Any questions? Yeah, Andrew.
What were you adding for nitrogen in those trials?
So the question was, what was the source of nitrogen? I think all these treatments would be balanced for the same amount of nitrogen, presumably something like urea to ensure that nitrogen wasn't a confounding or limiting factor.
I guess the purpose of the product, was it as a source of phosphorus, or was it also for some of the microbes to trigger a release mechanism from soil to root exudates back into the plant?
So these products would not contain any microbial activity because they would have gone through a incineration process to sterilize the raw material, sewage sludge ash. But then, ultimately, products like Pure Loop or other products that ICL produces, like triple superphosphate, could be the carrier for microbial activity to help improve the efficiency of the phosphorus that's being supplied to the fertilizer, or maybe some of the phosphorus that's already in the soil. So I think that comes back to one of my first points about complementary technologies going forward. It's not just about a nutrient source of phosphorus, whether that be triple superphosphate or Pure Loop. I think ultimately it's about a nutrient source, and then other components like the biology that can help us reduce the amount of phosphorus that we're applying as some type of external phosphorus. Thank you.
Great. Thanks, Joanna. Thanks again, Jason.
Okay, we're actually ahead of schedule, so feel free to ask lots of questions. So next we have Fred Nichols from Huma. Is Fred here? Oh, hey, Fred. Sorry. Where are you? Fred currently holds the position of Executive Vice President and Chief Sales and Marketing Officer at Huma since April 2023. Previously, they served as a board member at AgriCenter International starting from July 2022. Prior to that, Fred held various roles at Archer Malmo, including Vice President, Account Director from June 2015 and Senior Vice President and Group Accountant Director from July 2019 to March 2023. So I'll let you take it from here.
Thank you. So I'm going to stay with the Illinois theme. I'm from Galesburg, Illinois. That's nearly the hometown of John Block, former Secretary of Agriculture for the U.S. It's a big train community, a big farming community. And so I grew up there on a family farm with livestock as well as a variety of crops. We actually diversified the crops that we grew back in those days. And then I also operated the family farm for about 12 years while I was still doing the marketing and communications roles that I've done for a number of clients throughout my career. So I've always pretty much been in ag marketing and served a variety of companies from crop inputs to equipment to financing and livestock. So thank you very much for having me today. This is clearly, truly an honor. So what I want to talk to you about is how do farmers make decisions, right? You all have a role in influencing and in selling and servicing farmers. What process do they go through? So this is what you're going to see here is a reflection of maybe some of the things that I've done, my peers have done, but I'm out talking to farmers all the time. I'm getting this information. So this is kind of what you're seeing here right now. So this is actually kind of scary, right? So in the business to business world, that we call it, and this involves agriculture and farming, over 70% of the process is done before a farmer even picks up the phone or goes and sees a salesperson, right? So what does that tell you? Right now, it tells you probably need to be on the internet, right? You probably ought to have some website opportunities. You ought to have some content out there. But the fact that they're out doing this and researching this, should be very alarming. So we put together here what I call an 8-step process. No, farmers don't sit down with these 8 steps and diligently go from one to another, right? But this is essentially the process that they go through. And I'm going to kind of walk you through, each of these steps here today. So the first thing that one needs to do is you need to spark interest, right? You got to get their attention somehow in some way. How are they introduced to products? Well, first and foremost, farmers are very curious by nature, right? I mean, think about it. You put a seed in the ground and you watch it grow. You hope it grows, right? So all this curiosity kind of leads them to look into a lot of different channels out there as far as what they're doing. I can tell you that early on in my career, if you wanted to get fired in an ag marketing position, recommend doing a program during the spring or the fall, right? Because farmers in the field, they're busy. They're paying no attention to you. What are they doing now? Now they're in their glorified home offices, which is other cabs with their GPS, right? I mean, I'm an old school farmer. I took pride in straight rows, man. You drive down, you're going to see straight rows for me. I obsessed over those things, right? Now they just get in and click a couple of buttons and they go up and down and make straight rows. So it's kind of humbling, I guess, maybe when I see that happening. But nonetheless, they're in there. The tractor's driving itself, the sprayer, the combine, right? They're operating themselves. What are they doing? They're on the cell phone, right? They're checking things out. They're on social media. They're sending emails. They're looking at websites. So this is a good time to take a look at, marketing to them and sharing some information with them. If you're in the combine and you're looking at your yield monitor and you're going through a patch and your yield's not what you want it to be, how can I make that better? Right? If you're in your sprayer and you're going down the field, you see patches of weeds, like, gee, money. That's an opportunity to work with that farmer. So all kinds of different opportunities there that you can market in a variety of ways. So if you take away nothing from what I'm going to say today, I would encourage you to take a look at this slide here. So there is a litmus test that farmers go through, when they're going to purchase any kind of product. There is always three questions that they ask. Number one is, will it make me money? Number two, will it save me money? And number three, will it save me time? Okay. I understand there are other outliers, right? We talked a lot, great presentations today about regulatory issues and being responsible based on where you are and so forth. And so, yeah, that comes into play. Safety can certainly come into play, right? So there are some other issues, but really these are the big three. So I would like to invite you, think in your own minds with the products that you sell and you market, you represent, you counsel on, where we might lie in those three. So at Huma, we've got a product called Superphos. And it's a O50O liquid product, right? It's a phos acid product with our microcarbon technology. Applied at very low use rates. It enters the plant very quickly, right? That's a snapshot of the product. So if I'm looking at that, I'm thinking, okay, well, how's it going to make a farmer money? Well, we have done a variety of research trials, and we've shown some yield advantage to that, right? The fact that it's carbon-based versus salt-based. So, there's certainly some soil health properties that we can leverage there to make farmers money. And those who have opportunity to get some premiums for specially grown or for sustainably grown crops, it can certainly do that as well because you're reducing the amount of synthetic fertilizer, right? So those are ways that can make a farmer money. So how will it save them money? Well, right now, with our product, and you've all seen what the price of DAP is, right? We've got a very strong advantage as far as price per P when it comes down to that in the market right now. So that's saving them money. And then how will it save them time? Well, in most cases, this can be tank mixed, right? And that's something you take a look at, right? The convenience. You can tank mix it when you're going to do a burn down application or if you put it in your starter fertilizer. So those are some ways. That's just use an example of a product that we have on a litmus test there. But definitely those three always get asked. And you better be able to answer hopefully all three of them. Definitely two of them. If you only do one, you better do it really, really strong, right? So that's what they look at. So once again, how do we make our money? Well, clearly, yield certainly comes to mind, quality comes to mind, premiums that they might make come to mind, right? There's a variety of things there that can do that. Once again, how do you save them money? Well, yeah, maybe a lower price, but it isn't always about the lower price. Sometimes you can reduce labor costs, right? Sometimes you can reduce overall input costs. So sometimes you can make other products better, right? So these are ways to save them money. And then how do you save them time? Well, certainly efficiency, right? We definitely want to take a look at, how we can do that. One thing though to take a look at is this whole time element. So one thing I tell folks all the time is farmers are people too, right? So they want to spend time with their families just like we want to spend it with ours. We are kind of seeing a paradigm shift right now with the younger farmers, even going more into that direction of what they can do to save time, spend time with their family. The other thing that we have to look at, and this is kind of a scary number too, but about 80% of all income that goes to farm families are derived from off-farm sources, right? That's kind of alarming. Now, in some cases, this could come from a spouse. Often it can come from second jobs, right? So if you can make a farmer more efficient, if you can allow them to save time, they might be able to spend some more time working at a second job, etc. So these are all the type of things that we want to take a look at. All right, so then what they're going to do is they're going to go out, they're going to conduct some research. And I can tell you that spending a career in ag marketing, there is no silver bullet to reach farmers. There is literally no market segment like farming that has so many specialized media channels, right? Print is alive and well. Farmers read magazines every day, right? So that's still a very tried and tested method. Radio, there's stations that dedicate themselves and have programming just for farm broadcast, especially in the Midwest, right? You get some of these boomer stations like WHO in Iowa, it'll go throughout the whole Midwest. They got 2 hours a day, believe it or not, in just farm programming, right? So lots of different ways. You see billboards out there. Of course, there's all kinds of ways to reach farmers on the web and e-newsletters and just lots of different ways. Trade shows, right? They're everywhere still. But when farmers start making decisions, a lot of them prefer to almost be left alone early, right? What we're seeing is about 2/3 prefer what they call digital interaction early on in the process, right? They're out there doing research right now using their channels. McKinsey did a study recently that really confirmed this, and you can see as the buying cycle progresses, that's when they start wanting to hear from and talk to salespeople as they get further on down the journey, as well as once they've made the product purchase. So here's another, I guess, highlight slide that I would certainly invite you to take a look at. And that is any change a farmer makes to their operation impacts their entire operation, right? Farmers look at things from an enterprise level. A lot of times people want to sell specific products, and that's great. But farmers are going to look at it from the lens of how is this going to affect my entire operation, right? What changes do I have to make for my operation? They're very process-driven people. They have to be. So once again, always take an enterprise approach when you're talking to them. Okay. So after they do some research, they're going to seek some validation, or they're going to talk to their peers. Is really what it comes down to. Lots of different folks, lots of great folks in this room, very smart people. But the reality of it is the number one trusted source for farmers is other farmers. Always been that way, pretty much always going to be that way. That's why you see testimonials a lot, right, in ag marketing. Farmers want to hear from other farmers and understand their experiences. The other thing is all politics is local, all farming is local, right? So you want to make sure that whatever you're doing is tested on those soils, on those conditions, on those cultural practices, right? This is something that we see throughout. Once again, about 2/3 of farmers, they'll turn to their peers first, even before an agronomist. They also have inner circles of people that they deal with, right? So this could be equipment buyers. Clearly, ag lenders, right, are playing a greater role. Extension certainly would be part of this as well. Various consultants, but a lot of farmers like to get their little network of folks and run things by them. The other thing that we're starting to see now, of course, is with social media, and you're getting various opinions that way. Something that I really can't emphasize enough, though, is when people ask all the time, okay, who are the influencers, right? Who are the early adopters? Who are the folks that we really want to get out in front of? Take a look at the people that are on boards. You got Farm Bureau, excellent organization. You got state associations. Illinois Soybean Association is massive. National associations, all these kind of associations out there. The folks that hold these positions, trust me, they're held in very high regard, right? They're highly respected individuals. But a lot of them get on these boards so they can talk and interact with other farmers, right? Every year I go to Commodity Classic. I got a good friend of mine on the National Corn Growers Board. And okay, I'll admit, at night we go party hopping, right? All these state associations will have their individual parties, unsanctioned, of course, in their hotel suites. But they're all there talking to each other, learning from each other. I mean, it's really good stuff to see how that all happens. But those are the type of people that we have to take a look at. So number 4, okay, now we're looking at a price-value relationship. So where do you need to be at? Well, through the test of time, if you can deliver a 3-to-1 ROI confidently, you're going to get somebody's attention. That's usually a pretty good place to be as far as getting them interested in you. Not that you couldn't go lower, not that some go higher, but that's certainly a number that we see that people like. But of course, there's different groups of farmers, right? So we got specialty growers. These are folks more driven by quality, right? There's things that you might not think about that they take a look at. Shelf life of product, right? What you can do to help extend their shelf life, their harvest intervals, if you will. Produce being more eye appealing, taste, right? We know we had a conversation with the folks yesterday about bricks and where that might go. So lots of different ways when you're talking about specialty growers. Unfortunately, commodity growers still are all about cost per acre. I understand there's some factors impacting that, which we'll get to here shortly. But by and large is what's it cost me to produce something and what am I going to get out of it? And right now our trajectory in 2025 is we are set in agriculture to have the highest crop input spend in the history of agriculture. That's just where we are. And 2026 looks like it may break this year's record. So that's the reality, of where we are and what commodity growers have to deal with. Now, there are other angles, though. I love the presentation by the professor from Michigan yesterday, talking about, where we can maybe save some money on interest rates. Greenstone, by the way, was a former client of mine. Those are excellent people. So I'm so glad he talked about them. But that's certainly a unique way. Premiums, regen agriculture, right? We're seeing CI scores right now that are out there. They're still putting those things together, but there's opportunities there with the biofuel manufacturers. So there are ways to go about this that could be game changers, but by and large in the commodity industry, we're still kind of where we were. So I love to say farmer math, right? That's a term anybody works with me. They hear me say it all the time. Farmers are walking calculators, right? They don't need a calculator. They got something in their head. So they'll take a look at it and they'll immediately say, okay, what's this thing going to cost me? Okay. And that's not necessarily the true cost, but they're like, okay, well, do I got to pay to apply this thing, right? What's that going to cost me? So I add that up. Okay, now what kind of yield am I going to get? Okay, so then they calculate that and they do their quick numbers and their math. And I mean, you can be a salesperson and within 10 seconds, that farmer has already got a number in his head that he knows that he has to hit or she has to hit, right? So, just keep that in mind when you're dealing with it. So once they get that number calculated, then they'll go talk to a rep. And I can assure you, they are shrewd negotiators, right? In most cases, farmers walk into an arrangement, a deal, if you will, with the number in their head of what that product should cost, right? So that's just where they are. So then once they get to this point, we're looking at, okay, now it's time to do some testing. And we're seeing more and more of this with on-farm research, fortunately. A lot of farmers will have dedicated acres so that they'll just test products on. And that's really a good thing, right? It's a good thing for folks who are trying to market to them. Younger farmers are typically more apt to do this. It certainly makes sense. But there's a few things you've got to take a look at. Is these are also time consuming, right? Farmers are going to have to stop what they're doing, change over their planter, etc. To make all this happen. But on-farm research, it's happening all the time. But the best advice I can give there is don't let them plant it and forget it, right? That happens a lot. The companies will get a farmer to try something, and then later in the year, okay, well, what did the yield say? Well, yeah, I'm not sure where this was put together. Or the other thing we take a look at is yield. While it's the ultimate measure, there may be lots of complications. As we know, a lot can happen between April and October, right? So in many cases, it behooves you and your folks to be out with farmers, examining what they're doing. You might take some pictures. You might find out that, hey, this product created a great crop stand. Well, there could be some weather events, etc., that could happen later in the year that could, mitigate the yield opportunity, just nature being what it is. But if you've documented what's happened throughout the season, certainly you could go back to the farmer and say, well, look, these were the advantages that we had. We had a weird situation happen that kind of keeps you in the game there, right? So that's really part of this, measurement for success. I mean, yield is clearly going to be an ultimate measure, but it isn't always about yield, right? It's ROI. So we have to take a look at that. Now it's decision time, right? To buy or not to buy. So if that product provides the level of ROI the farmer is comfortable with, if they like what they're seeing there, they'll likely move forward. Doesn't mean they're going to adopt a product on all their acres, right? They may want multiple years, but it's something that be favorable for you. But keep in mind, however, that it's a lot easier to get thrown off the farm than it is to get put on the farm, right? So you are constantly being evaluated by farmers, year in, year out, as far as, how that product's performing. So I appreciate your attention. Thank you.
We certainly have time for questions. Yeah. Thanks, Fred, by the way.
I know a lot of times I'm thinking of like something like an equipment purchase or technology. That can be hard to test out on a small scale on a farm. And so a lot of times you're relying on like a field day or a demonstration plot. Any advice for putting those things on to kind of get around that step of if you can't test this on your own farm, how do you still get that confidence that this will work on someone's individual land?
Yeah, I mean, field days have always been popular. You don't necessarily see as much of that as maybe you did at one time, as far as bringing the masses out there. Technology, is kind of tough, but simulators, right? So there was a product that I worked with at one time, and we literally created a simulator that could show how that product works and how it functions. Video, right? The use of video and technology to showcase technology is certainly something. YouTube is highly popular, right? So really, you cannot be a successful marketer these days without utilizing those video channels. So I think that's certainly something. But then getting people to talk to one another, right? That I would really recommend that. Getting your users talking, going to events. Commodity Classic, is a great one, but there's other, local type events as well that you can get the folks who have used it and can kind of give their testimony to it. So yeah, it is a little tricky. It's not like taking a tractor out to a farm, right? Let them demonstrate it. I know what you're talking about there. And I would say the use of video is probably your best bet.
Thank you. The three questions, does it save me time? Does it save me money? And what's the third one? I forgot.
Yeah, does it make me money?
How much does it cost?
Yeah, yeah, that's kind of where they're going. Yeah, does it make me money? Does it save me money? Does it save me time?
Right. Can you speak to what thresholds there might be in each one of those? I know from experience, will it make me money? Certain farms, you can demonstrate moving the needle for them by as much as 15-20%, and they will still not commit because maybe it doesn't address the other questions. But anyway, yeah.
Yeah, no, I think that is a great point. So, farmers have the old pain in the what, aversion. And to get them to change what they're doing can definitely be rough. I've worked with companies where, hey, we got this great add-on to put on your planter. Well, someone's got to put that on. Someone's got to maintain that. Someone's got to service that, right? So some of these things that sound whiz bang, really aren't. So that's kind of where the Batman and Robin of this, right, was any change a farmer makes to his operation impacts his entire operation. And that's really what you got to look at, right? I mean, if you can stick a product in that could be tank mixed with another product, for example, Okay, now you're helping, right? So will it make me money isn't necessarily the overriding, because you're right. You can show high value, but if it's going to take additional labor, additional hassle, additional disruptions, I mean, let's face it, the way farmers are right now in the crop commodity market is farmers want to plant all their corn in 1 week and all their soybeans in 1 week. And not necessarily in that order anymore. That's a whole different conversation. But that's what they want to do. And any disruption to that, now they're looking at the long term, how's that's going to impact my harvest schedule, my potential yield, my labor situation. So yeah, they're looking at all of these things. So that's why the best advice is look beyond just your product. Look how it impacts, the entire operation. Great question. Yes, Doc.
Great presentation. Really enjoyed it. I work in extension, so I like to see this perspective. I think I can be a better communicator now after knowing more about the farmers. So, how often do you think there is a number four that it makes sense to me, but dad doesn't agree?
12 times a day. Yeah, you see a lot of that. It's pretty funny. I tell you a joke. So I worked with the Cotton Board at one time, right? And great people, right? Just loved working with them. But we kind of had a joke that you take a look at the Southern farmers, and they say, okay, the son might be the one operating the farm, but he didn't live in the big house, right? And the joke is, why doesn't the son live in the big house? Well, because daddy ain't dead yet. And that's kind of where it goes, right? It used to be that who was the one that would always operate the planter? The old guy, right? I mean, that's just, dad would never let the son, much less have him feed the grandson, operate the planter. We are seeing, though, technology change that. So as we're looking at large farming operations, they are doing some dividing and conquering, right? So in some cases, you might see someone going to college and getting a business degree, and they might be responsible for marketing and bookkeeping, right? That could be a son or a daughter, for example, or an in-law. You can see somebody in charge of equipment and equipment maintenance, someone in charge of technology, right? I mean, you take a look at these platforms, Climate and others that literally run the farming operation. Someone needs to know what they're doing there, right? Not to mention the GPS data and everything else with the yield monitors. That's an area of expertise, right? So you do see some of that, philosophy now where they're starting to divide and conquer, but there is no denying that the old guy is still the CEO in many respects, and yeah, you got to have a compelling story to get him there.
Okay, folks. So what I'd like to do is first thank Fred again for his presentation. Thanks.
All right, so next we have David Emmerman, and he became District Chief of the Northeast District Office in January 2023. David holds a law degree from Cleveland State University and degree in environmental science and chemistry from Miami University. His previous roles include Assistant Chief of the Division of Surface Water, General Counsel for the Ohio Lake Erie Commission, and litigator for the Ohio Attorney General's Office. So turn it over to you, David.
All right, thanks so much. Everybody take a breath, right? You deserve and you expect clean air. When you turn on your faucet, you deserve and you expect safe, clean water to come out of the tap. I'm David Emmerman. I'm Chief of our Northeast District Office for Ohio EPA. It's my job to help facilitate clean water, clean air. And when you come up and visit me in Ohio, and we go fishing and sailing on Lake Erie, right? You deserve Lake Erie to look like my shirt and not like my tie, right? This is where I get involved in phosphorus. It is a very, very small part of what I do, but a very important part. And I was very impressed by all the speakers at this conference, because I don't have the technical background to really understand what what's being presented, but you all present it in such a way that I've learned so much, and then can take it back to Ohio EPA, to Ohio, and try and apply it so that we can solve our problems with harmful algal blooms on Lake Erie. So here's a little bit of a change topic. New research at Ohio State has shown that it is worse environmentally and hygienically to use soap when you wash your hands. Vinayak, will you come up here? I want to do demonstrations. Vinayak, and so I asked him, I said, do me a favor. I said, for 2 days, don't use soap when you wash your hands, right? And there are new technologies out there. So this right here, it's very precise, right? It's a very precise, dialed in light source, right? That pulsates, right? And if doing this instead of soap, right, will be better for the environment, right? And pretty much equivalent for soap. So if you could put your hands out. This won't hurt.
The next speaker, you're not.
Yeah. So yeah, just put your hands out, right? I'm gonna down like this. This shouldn't hurt.
I'm shaking.
Yeah, this shouldn't hurt. I know this shouldn't hurt. No, it maybe it's a little numb, right? And that's it. That's all you need, right? Put your hands up. You can't tell the difference, right? Between that, right? That's our control, and this is the. But you know, if we put a microscope under this, right? You'd be able to tell, and all of the reports out of Ohio State say that's the case, right? Obviously, I'm joking, right? I'm obviously like this is just making this up. But what would it take to convince you that that was true and to change your practice? What would it take? One Ohio State study, 2 Ohio State studies? We can pile them on, right? But the reality is this, right? It's like, this is not fantastical. This has happened, right? Think about 20 years ago, trying to convince folks not to use talcum-based baby powder, right? Do people know what the issues with talcum-based baby powder are, right? 20 years ago, if you said, oh no, talcum-based baby powder could cause cancer, right? Or wait, what about Teflon and pans? Think about that 20, 30 years ago and saying, oh yeah, don't use Teflon pans, right? So it's not fantastical to say that like some of our assumptions, right, are tough, but then to convince somebody to change their practice is very hard. So Fred, what a job of what it takes to convince farmers to do something that makes them money and saves them time. But what if it was just equivalent money, equivalent time, but better for the environment? What would it take to convince them then, right? So you think about like this not washing your hands thing, and you can think about the arguments that somebody made. I've been washing my hands for the most part my whole life, right? My grandfather washed his hands, right? Or if they actually changed to this practice like I have, right? Just kidding, right? But if they changed to this practice, right? Then you say like, all right, well, I've been doing this for 5 days, a week, a month, and I haven't noticed any difference. Or, hey, I did this once, and then all of a sudden I got sick the next day, right? And then this is complete garbage, right? And then the big soap lobby, right? The big soap lobby is gonna come and be like, oh, Dove soap's gonna be like, now this causes cancer, not our soap, right? So for myself, having this being a small part, I was working at the Ohio Lake Erie Commission, and we've been having these harmful algal blooms, and we kept getting approached by these really innovative technologies. I'm not an expert, right? I know very little about farming, and farmers can tell the second I walk onto the farm with my shoes like this. I'm just kidding, I don't. I do wear boots, but as soon as I walk on the farm, they know, right? And so these folks, they approach us saying, "We have your solution for harmful algal blooms." I said, "Oh, that's very interesting. What is this, right?" And some nut job at the Andersons. Just kidding, Chuck. Right? He hands us this and said, "This is your solution," right? No, I'm going to stop picking on Chuck for a second. Let's say somebody else, right? They come to me and they say, "All right, this is something that's innovative. It will solve HABs." I said, "Okay, how does it work?" "Oh, it's proprietary. I can't tell you." Right? See? And by the way, I know the governor personally, and if you don't do this, you're going to get fired and criminally prosecuted. Right? This is the type of pitches that we were getting at the agency. But then I went to a place like Chuck Anderson's, right? I went there with my boss, Joy Mullings. And Joy and I walked out when Chuck was talking about Smart Phos, DG, right? And we thought, this sounds so promising. And there were a few others like it too. We're like, this sounds so promising. We need a process. We need a way to be able to advance some of these innovations in Ohio. Why are they not being done in Ohio? So I created the H2 Ohio Technology Assessment Program. And knowing nothing about farming and very little phosphorus, first I read the Devil's Elements, so I read the book, so I got a little bit of background. But we put together a cross-sectional team. So the public sector on the bottom, private sector, and NGOs, trade associations, people that we felt were respected in the industry. So like Ohio Farm Bureau, right? Or it's not listed up here, but coordinating with our soil and water conservation districts. Big companies like Moen and Scott's Miracle-Gro, right? People who had the respect and the knowledge to be able to evaluate some of these technologies. So then we did our request for technologies. We said, all right, give us your great ideas. Give us your innovation. This group narrowed them down to the 10 that we thought was the most promising. Not that the others weren't good, but the 10 we wanted to keep going with. Then we sent those 10 to a third-party consultant. At this time, it was Tetra Tech. And they did an in-depth review of conceptual model review, data gaps, risk assessment. There was like 10 things. It was very long. You went through the process.
It was brutal.
It was brutal, right? But what the advantage of that was, because it's so brutal, is we now have some defense on our side. We can say, all right, if we do want to go forward with some of these technologies, which we do, external parties have looked at them and gave us their thumbs up, right? We had a third-party consultant do an in-depth review and was able to sign non-disclosure agreements so that they could go through the proprietary information. It's a long report. I didn't even read it, right? I read it. I'm kidding. You put all that work into it. I read it, right? But no, I took that report and then we started going to look to fund demonstration projects and say, what do these need to gain market share in Ohio? How can we use these to help solve the problem? Amazing technologies came out of it. We got almost all of them funded with field studies because, as Fred said, right, these farmers, they tell me, like, don't show me a 1-year study. They said, because that's what I proposed. Oh yeah, we'll do this for 1 year. Like, I'll just throw it out. Like, I don't even want to look at it. And they say, being in Ohio, they say, don't show me some field study down in Columbus. I said, I'm up in Toledo, right? Our soil is different. Our weather is different. Because I want it on my neighbor's field, right? And so as we looked at, well, how do you get these market share when a lot of these aren't going to save time for the farmer, aren't going to save money, but I generally found, and I'm sure all of you have, is that farmers also tend to be on the forefront of conservation. They care. They care about their soils. They care about the water. But they're not going to do it if it just looks like this, right? There needs to be some backing behind it. So this DG Struvite, this is one that we helped to get funding for a demonstration project. In a bit, Vinayak's going to come up and talk about how Ohio State, very respected organization, is doing the third-party assessment of this on an actual farm field in Northwest Ohio. We have one that was automated drainage water management. Another one Vinayak is doing research on, right? This is your example, Fred, right? Does it save us time, right? We found one of the biggest problems was with this manual drainage water management, where people had these manual gates that they had to change. They could adjust the levels of water on their field tiles. It's like, yeah, that could work great. But boy, going around every field, like, how many times a year are you going to do that? So the innovation was now we have automated drainage water management. You could sit in your combine, playing your video games, water level, right? But so we looked at those barriers to say, how do we break down these barriers? Right? How do we make it so that these can be adopted? We're doing a fun little experiment. Right? We got 5 fields with automated water drainage management where the farmers are controlling the water level. 5 that Ohio State are. Who's going to win? Who's going to get better results? Now we have competition in there. Right? These farmers, they don't want to lose out to Ohio State. But it really goes to show that it's about adoption. It's about kind of creating excitement. Manure is a big thing. I see and we see manure as a potential resource. We have a lot of manure coming out. The problem with manure, as was described earlier, is that it's very concentrated, right? So they have their fields that they can move out to, but we want to extend that reach. We want to extend that reach so that it's we want to extend that reach so it offsets commercial fertilizers. Or how do we make it more stable? And what we found is really it's about separating out the nitrogen and the phosphorus. So we have, and it's going to sound exactly like this. I know what I'm about to say. We have one technology that we're piloting with the Cleveland Water Alliance, put out by a Nurendorfer. They make air pollution. They can send precise electrical signals through manure, and they lyse the cells. The phosphorus precipitates out to the bottom, and now they have concentrated semi-solid phosphorus on the bottom, and then the top is just liquid with water and nitrogen. And they use center pivot for that, and then they have high-value phosphorus they could dry out and haul away. We found that when we separate out those phosphorus and nitrogen, that's when we get the economical value, right? And all of these economics are working through our partners here. Another one where we're doing a study from the hog farm all the way to the crop producer, where they are doing a process where it very quickly switches between a basic and acidic solutions. So, adding lime and adding acid, right? And then that will precipitate out the phosphorus. Then they have a separate system that will create the ammonium salt for the nitrogen. And when you separate out those streams, you can then optimize for both nutrients. Looking at our manure as a resource, not a liability. And that's a big shift. This is where we come in with saying, like, all right, then how do you save time and money with that? So then we're pairing it with the crop producer. So it's the whole value chain, looking at that whole value chain. So the crop producer says, yes, I want that and I'm willing to pay for it. And then the hog producer saying, yes, I'm willing to spend a little extra money creating extra value to my manure so that it's going to go. So these have been so successful that we are doing round 2. And so the Andersons had such a great experience with this. They said, we want to give back. So Cleveland Water Alliance, the Andersons, and then Ohio EPA, we are co-chairing the next round of H2 Ohio TAC. We've been working very hard with new partners. We want to specifically target legacy phosphorus and ways to make legacy phosphorus more available to our crops in Ohio. Again, our goal is halves. Farmers' goal is getting the phosphorus into their crops, right? Our goals are aligned. But so we have more farmers now on our panel this time than we had before. So some really innovative farmers who are willing to take risks and willing to kind of push the bounds and speak up in their communities and help address this. So I'm happy to announce. I was hoping to actually announce it today, but we have approval. This request for technologies is going to go out within the next month, right? So we are looking for your ideas. We are looking to send them through this process and do demonstration projects in Ohio, in the Northwest. One of these folks, they told me, like, all right, we have this great farm right across the border in Indiana. It's 1 mile from the border. Said, no, move it 1 mile the other way and then do it. So that's what they are, right? So this is going to come out very soon. We're hoping that you submit your ideas. We're hoping that you come to us. We want to drive innovation in Ohio, and we want you to come and test your things out in Ohio. So Vinayak is now going to talk about an amazing study that we have testing one of these out and some of the results of this long process. Thank you.
Do you have a few minutes for questions for David, if anyone has any questions?
Questions?
All right, any questions? I'm pretty much going to defer them all to Vinayak. Go ahead. So I don't know what I'm talking about, and you know that already, but okay. What are your questions? All right.
Tell us about lysing manure into phosphorus and nitrogen.
Oh yeah. So that's very cool. So essentially it's like a big pump that comes on a trailer. They have a generator and a pump. They pull up. So we're really targeting dairy farms with this. The other technology is specifically for hog manure. This one is for cow manure. And they pump out the manure. It goes through this electrical process where they're shocking it and goes right back into the to the lagoon. And then you very much noticeable right away that you can't smell it. Like it kills a lot of the pathogens as well. So we also see applications for biosolids. The reason why they applied to us was they licensed this technology. It came out of Israel. They licensed this technology, but they are an air pollution control company. And so I don't know, have anyone dealt with coal plants before, and air pollution control in coal plants? It's very similar. They have these electric scrubbers, right? These precipitators, and it's like the little particles kind of get attached, and then they zap it, and it's like this loud kind of electrical zap, and then it all falls to the bottom. So this is in line with what they do, but they have a lot of connections to the coal industry, very little to farmers. So we help connect them to the farmers that they can test this on their fields and with their lagoons.
So this is similar to a wet ESP?
Explain that to me, please. Vinayak, explain it to me what that is.
Wet electrostatic precipitator.
Oh, no. They have experience with electrical conversion, right? So it's in their wheelhouse, but it's not similar to the air pollution control equipment. Okay. It's just that their expertise is aligned because their expertise is in that kind of power conversion.
Other questions?
All right. Well, thanks so much.
Oh, you can eat that. Okay. All right. I eat it. I need to keep my hands. I did wash my hands. Oh, this is not staged. Shook a lot of hands today, so
Good to have that clarification. Okay. No, stay here. Dr. Vinayak Shedekar is an assistant professor of agricultural water management in the Department of Food, Agriculture, and Biological Engineering, or FABE, at Ohio State University in Columbus, Ohio. He also serves as the director of the International Program for Water Management and Agriculture and the Overholt Drainage Education and Research Program in FABE. Turn it over to you. Okay, great. Well, we have a great panel here. I have a couple of questions prepared, and then we'll open it up to the group. If you wouldn't mind keeping me on time, Matt. So the first question I had, and there's been a theme throughout the last couple of days about time and how time is so important and limiting, especially in the research setting. From a funding organization, we often fund projects in 3, maybe 4-year spurts, which often isn't long enough for some of these important phosphorus topics. So my question is, considering how valuable time is and how long some of these projects can take, are there any ideas around, tools, processes, national infrastructure that could help assess products maybe more efficiently and effectively for, farmer demand and in the shorter intervals?
Me to start?
Please.
Sure. I can. Well, I came here with some sort of a fresh thinking about when Chuck and I talked, I very quickly said that, Chuck, what we're doing in Ohio, how far can you take this beyond Ohio? Just like Fred mentioned, farmers want something from within their county. I think there is a possibility where you could think of a kind of a coordinated network that actually is testing these products at the same time. That does not get you close to the long time that you need for research. It's a very slow process. I think by the time I retire, we'll have an answer on this one. Uh, I don't know if there is a faster solution other than taking help from modeling to gain some insights and really trying to ramp up The other thought I have is citizen science, really working with farmers and giving more power to them to be able to actually do more scientifically sound studies to some extent, but it's easier said than done.
So, I'll say, everybody wants to do things faster, right? But we also don't want to make snap decisions and kind of rubber band back and forth on things. So, our goal is to reduce harmful algal blooms in Lake Erie and some of our inland lakes, right? And we're looking at all the tools for that, not just on the agricultural side, but on the wastewater side, on non-contact pooling waters, and all of these make an incremental difference. But like somebody said, there's no silver bullet here, right? So we're doing a lot of little incremental steps to address harmful algal blooms on all angles. And so we're starting this round 2 of the HR Technology Assessment Program while the demonstration projects are still going on in the first round, right? So that we have a pipeline of these, so we continue to evaluate and put forward new innovations to address harmful algal blooms or otherwise better manage nutrients. So yeah, speed is always great, but slower incremental steps is how I think you make a difference in the long run.
Yeah, agriculture takes time, right? By nature of what it is. I mean, the greatest agriculturist of all time, um, he ended up going down to Mexico and accelerating the genetic process, right? Norman Borlaug. And that was one way to, they won a Nobel Peace Prize. It's one of the many reasons he won a Nobel Prize. But those are the type of out of the box thinking that we have to do. I think coordinating efforts and communication is definitely the key.
So I have a couple of thoughts, and this is maybe a shameless promotion for the EFC, but I think that's a great example of how industry and academia and other partners can come together to really focus on big picture topics and pool resources to go faster in answering those topics. And then you mentioned modeling. I think that's important too because from an industry perspective, our resources, our funds are limited to trial products. And you pick a product and do a trial on corn and potatoes, and then inevitably somebody says, well, what about the performance of this product on citrus or strawberries? And it's just this never-ending cycle of doing more and more trials, and you never get a concrete answer that anyone is really happy with. And you might have data on potatoes, but it's not good enough that you have data on potatoes in Michigan if somebody's based in the Pacific Northwest. So I think having a framework, like that established by the EFC to really focus on the key pieces of information and then support that with modeling that can at least point us in the right direction of how it would perform in other environments or other crops is really powerful.
And to have good models, you need good data, right? So getting all that data first is so important. Okay, does anyone have any follow-up question to that topic? Well, I also wanted to ask, Fred did such a great job enlightening us into like the workings of farmer decision making. That was really, really helpful. So I also wanted to ask, maybe from an industry perspective, what is incentivizing industry to develop more efficient products? So what's the driving factor there?
Yeah, so that's a whole day of conversation, right? If you take a look at the food companies, the CPGs as we call them in slang, if you will, right? They're the ones who are going to help, I think, drive a lot of this. I think there was some government participation with biofuels and where that's at and where that is, not quite sure right now. But definitely, I think industry, I think investors. I mean, once again, the gentleman yesterday from Michigan gave a great talk and follow the money flow. But right now, the amount of sustainable investors is just massive, right? And these are folks that are looking to invest their money in worthy projects that they deem is gonna be earth friendly, right? So there's money going there. The food companies are seeing that money, all right? So they've got two paths that they want to travel. One is for those type of shareholders, but then the other is the consumers, right? As consumers become more educated, you take a look at, from the baby boomers, down to Gen Z, I guess is where we are, in grocery stores. They want to know where their food comes from. They want traceability, right? They want transparency. And, these food companies know that. And they're looking to differentiate themselves and their brands. So are restaurants. So I really think this is where it's going to come. Private industry right now is going to get competitive. They're going to cater to some of these needs that consumers have. And that's where incentives, we're already starting to see that, right? Is where they're starting to come from. It's going to evolve.
I think I would add to Fred's comments and approach it from the perspective of a mining company is that you have a phosphate mine or a potash mine or any type of mineral resource. I mean, that's a multi-generational asset. But realistically, there's a limited supply of phosphate in a mine, and you don't just flip a switch overnight and create a new phosphate mine, and that may not even be possible for some companies. So I think approaching it from the realistic standpoint that that natural resource is limited. It's going to run out at some point, and then if we innovate and develop new products that are more efficient, we might sell a little bit less, but it helps to extend that asset over multiple years.
Yeah, that's great. And I have one more question, kind of a personal interest as we're looking at different technologies in our program is, there's some technologies that are really weather dependent or don't work every year. And Fred mentioned, it's really easy to get kicked off of a farm if it doesn't work one year. So what do you do with products that might be a little more nuanced and may not work in every situation or every year? How do you handle that conversation with farmers?
Yeah, that's certainly difficult. I mean, that's a challenge, and that's why I mentioned earlier that document the progress of that crop, right? I mean, I think that's just essential. I mentioned earlier how often they plant it and forget it. And it happens all over. I mean, I've worked on trials. I'm guilty with good friends of mine that farm, and yeah, well, yeah, I guess it's okay, whatever. That's kind of the stammering that you get from some of these guys, right? It's just the reality. But documenting, I think, makes a lot of sense, right? We know there's events in every crop's life that we need to document, right? We're talking germination, we're talking emergence. As we can talk about plant height, as we can talk about, where are we at different stages, how fast are we to different stages, etc. I mean, the more we can document these things and give us a nice data set, the better off we're going to be. Because yeah, otherwise you're susceptible to some unforeseen weather event or pest event or whatever it might be, right? At least this way you can come back and say, well, you know what, we improved stand count by 10% or whatever that might be, right? That certainly is something that a feather that you can have in your cap to utilize and convince people. Well, we were on a great path, and then you got a historical flood or whatever that might be, right? So this is definitely why and a motivation that we want to document what we're doing.
So from our perspective, we do see this as something gets a bad rep, and that's it, right? And then it's hard to overcome that. The manual drainage water management was that in Ohio, right? We put in a few of these and others did as well, but they're like, oh, it made no difference, right? And now that I have this automated technology that wants to take hold, it's fighting the legacy of these manuals. And then I keep explaining, well, the problem with the manuals was people didn't want to turn the things enough, right? And so we do have that issue. That's also where the government comes in, right? Because then we can fund these multi-year studies and a variety of products and kind of see where we can drive innovation. But it's never all our eggs in one basket. And I'll just say, so for the electric cell lysis, right? I was out there with the farmer and it was running through and, he's getting this for free, right? But we also got some resistance from farmers. They was like, nah, I don't want you to study on my lagoon, or I don't want you to haul this thing in, right? And so I asked him, I'm like, what's your interest in this? Why are you looking to do this? He goes, just this stuff doesn't cost me anything and seemed easy and, you're only gonna be here for 2 weeks, and I forget if it doesn't work, right? Yeah. It's like, all right, right. So it was like a low risk for him. But we'll see, because he might just come out with this and say, I didn't notice any difference, right? When he looks at the data or not, he might just dismiss it, and then it kind of gets a bad rap in that neighborhood, right? So yeah, there's always the risk of that, but also to your point of speed versus just making slow incremental steps. That's our plan. Slow incremental steps that build off of each other.
I'll just add a couple things to the risk part of it. I think we all are focused on an industry that actually has the biggest risk from the weather-related factors. Well, if you look at the risk management agency's data for the last 30 years, weather-related damage is more than 75-80% of the damage reported to the crops. So unfortunately, that does happen. Other than this technology, we're talking about water. I deal with drainage and irrigation a lot, and this question often comes up. David, one thing happened on the automated control drainage project is one of the farmers in July, we got so much in July in Defiance County, we got 4 inches above normal rain. And our hope was that you're retaining that water in the profile, saving it for the summer for the farmer to, for the crops to utilize as additional water. But what do you do when you have double the amount that comes in July and the roots are drowning? You let go of that water. You don't need all that water. So I made calls and we opened all the structures up, let the water go for about a day. And I called them up again and closed the structures. However, one of the farmers got anxious. He did not want to sign up for it again. Like he did not want it to be closed. He said, I do not want my structure closed. I want that tile line to flow as much as possible because I'm worried about my crop. I let that happen. And now we're sitting in the drought here. Guess what? That field actually is going to yield lower.
He's gonna regret that.
The same guy has 2 other fields with control structures that were actually managed. He's gonna see the difference on his own. So I think one of the strategies when we have time on our research is to let the failure teach you. And that is what happened in this case. The other equation that we have implemented in some of the field research is if you do have enough space, you might want to have both of the crops coexisting in your trial in the same year, so that if you're going through a drought year, both crops went through it, and that basically shortened that timeline. But also you now have a use case to talk about for both of those crops. But it does get bigger and more expensive to do that kind of a trial.
I want to go back to Fred's comments, and yes, there's many non-yield related responses that we can point to in the absence of a yield response. But I think as an industry, we also need to get better at understanding what our products are truly doing. And it's maybe not as relevant to basic crop nutrients, but especially with biostimulants and biologicals, there's a huge gap of knowledge in terms of the mode of action and how those things work, and more importantly, explaining it to a farmer in a way that is understandable. Again, with biostimulants, going with gene expression data and saying that, this biostimulant increases, a specific enzyme under stress conditions. It's scientifically interesting, but, how can we connect it to, your 3 questions of, does it make me money? Does it save me money? Does it save me time?
I mean, what a finale to the last couple of days. The wealth of knowledge here. Thank you all so much. Do we have time for any more questions?
If there are questions in the room, we've got 5 minutes, and then we'll put the wall up, and Jim will have a few closing comments, and then we'll be done. So any questions in the room? Yeah.
All right, I think this is probably going to show my ignorance of the Midwest and corn growing. But I'm curious because we've talked about now some of the impacts of weather on these trials and things like that, but I haven't heard anybody really speak of changes in seed genetics. I know these are also fields that are kind of coming along pretty quickly. And is that having any impact on what you're seeing and the things that you're doing?
Yeah, it's rapid. I mean, it's just, if you just take a look at the stats, and I know back in the day when I worked with Pioneer in the 90s, 80s, 90s, I guess, we talked about genetic progress, being one bushel better, a year. And you take a look at where we've been, even the last 5 years, the last 10 years. I mean, it's just a vertical line upwards, right? Now, one could argue that's kind of why we're in some of the market conditions that we're in right now, but that's a whole different conversation too. But clearly, their genetic potential has just been through the roof as far as what these companies have been able to deliver. And I think a big part of whatever nutrients or whatever, I think that becomes a challenge, right? And a lot of times people talk about crop stress and the fact that drought or something bad happening and crops need energy and they need to fight stress. But the other way of looking at it is if you do have a racehorse hybrid and you got some good conditions, that plant takes a lot of energy, right? So this is where I think biostimulants, for example, will even have a greater role. Yeah, I get it during drought, during a hail event or whatever, but what about those years where now we can really make some hay and we're going to see some big, high-end crops, right? You got to feed those plants just as accordingly as you do in times when maybe the conditions aren't so favorable.
So to add to that, my graduate research focused on the effect of genetic improvement in corn on nitrogen use efficiency. And one of the main outcomes or conclusions of the research that I did was that modern corn hybrids, take up more nitrogen later in the season compared to hybrids from the 60s and 70s. And while that was focused on nitrogen, I think that same late season nutrient uptake effect extends to other nutrients as well, like phosphorus. So the implication is as we design agronomic recommendations and products, I think we have to consider the timing of nutrient uptake and extending that nutrient uptake throughout the growing season. And it's not just corn. Strawberries are another example where with some of our product lines in ICL we see less demand over time in the California market because there's different strawberry genetics being used that are more nitrogen use efficient, and they still need nitrogen, but it's a lesser amount compared to some of the genetics used in previous years.
Yeah, how often do you hear farmers, well, once you used to the old adage that, once you had the tasseling and once pollination, now the crop's made. Now I can go on vacation, right? And I think we lose sight of how much yield can be attained after tasseling, late season, whether you're watering, whether you're feeding that crop, right? I mean, I admit it, a year like this, when the economics aren't favorable, it's a tough conversation to have. It's hard to convince people of that, but there is a lot of yield left on the table, from folks that just kind of give up on the crop or think, okay, this is where I'm at. Well, when you still got 40% moisture in a kernel, there's things you can do to nurture that to make that expression, happen even greater.
The only thing I would add is I think a lot of times the um, farmers end up doing a lot of optimization eventually based on what they have available. I had the opportunity to work with David Brandt, who is known worldwide for like soil health, no-till cover crops, 55 years of no-till and cover crops. That guy was 3 years ago, he was still experimenting different hybrids for his own operation because he had a very different system. And hence, he needed to see what the response was from different hybrids that are coming in, what works in his system. So a lot of times it feels like it's going in that direction where the farmers are also doing a lot of experimentation that helps them. It's interesting that the farmers do a lot of experimentation that doesn't necessarily get reported on especially topics like genetics. The other side of it is what is the true potential you can reach in managing some of the abiotic or biotic stresses that you actually are modifying these crops for. For example, I often get the question and I don't answer it is, can you ever create a drought tolerant corn that would also survive the wet feet during spring with genetics only? And I don't know the answer to that, but there are these other factors that play a role where maybe that technology has a certain limit. Beyond that, you're looking at other factors or cofactors as a response.
Ma'am, to your other point of your question is, the genetic expression of where we are with just the genetic potential. Go back to Francis trials, right? he would put a Coke can on a planter box and he'd go up and down the field and he'd make sure that if that Coke can would not get knocked off, that's what he wanted. So, but how do you get that, right? Well, you're working that soil, you're doing heavy tillage, you're making things very, very smooth. Well, reality of it is he had the genetics at the time that he had, right? And I think a lot of times people want to blame farmers for maybe mismanaging and getting the condition that we are. And I'm not saying that they've been perfect, don't get me wrong, but usually you can only control what you can at the time based on the technology and the resources you have. That's why he farmed that way. Now, when you see guys going over cover crops, right, and just rugged and where things are going, well, we've got genetics that are designed, to break through different type of crusting in soils and to go penetrate through cover crops, and that's allowing us to utilize some of these techniques, right? That's for the betterment of everyone involved.
Gary.
Yeah, this might be a dumb question, but I'm good at those. I would think also that another thing that is going to drive and is going to force innovation both in genetics and in in cultivation practices over time is potential higher peak temperatures in the central growing season due to global warming.
You want me to take that?
Yeah, go ahead.
Certainly as you get temperature spikes, and I think you're starting to see some things with planting dates, right? So once again, going back to those genetics, right? A funny story. So when I was still farming, I was in central Illinois or west central Illinois, and I was planting beans in April. And one of the reasons why I did that is because I had a second job, I had some travel coming up, and I saw a weather report. I'm like, well, I'm going to give this a try, right? So I'm going down the row, and all of a sudden, this old timer comes, Dean Simpkins, and was pulling up in his pickup truck. And he said, "Oh, Fred, looks like you're finishing up corn, huh?" I said, "Dean, I've been done with corn. I'm planting beans." He goes, "What are you doing?" And I'm planting beans. "Fred, it's April. It's April 22nd. What in the world are you doing? Anybody knows you don't plant beans until May."
Yeah.
Well, ended up being the best bean crop field that I ever had, right? So we're starting to see that. So that's a great point. But once again, these genetics now are allowing people, to get in the field earlier, to mitigate that stress. And that way, if you can avoid, right, with corn pollination, some of the heat times, or allow you to utilize soybeans to capture as much light as possible, it's going to be better off. So really, a lot of it does come back, even though we're in the fertility business and crop nutrient business, there's no substitute for what genetic progress has done for us.
Great. We'll leave it there, folks. Thanks so much to the panel. Thanks, Sarah, for moderating.